What I will encourage you to do is to be asking as many questions as possible, because example is more efficacious than precept. The more questions you ask, the more your brain is open. You see, your brain doesn't like to think. That is why it thinks. And so if you want to do well, you have to ask as many questions. So let me quickly ask you, what's the name? Ernest, what is 7 plus 7?
No, please, it's 14.
Good. Did you think about it or you didn't think about it?
No, please, I didn't.
Exactly. Your brain doesn't like to think. That's why you didn't think about it. So what you got your answer from is from memory. What is 784 times 98, Ernest? Ernest, at this stage, what are you doing? At this stage, what are you doing?
I'm thinking.
You're thinking. But you didn't like to do that. You would have wished you had given the answer earlier, isn't it?
Exactly.
Good. So that's what a brain is. Okay, your brain doesn't like to think. That is why it has to think. Why? Because the next question I asked you, you don't get the answer from memory. You get the answer from imagination. You get the answer from imagination. Okay, but the only way the brain can undertake imagination is the highest form of knowledge. The only way your brain can go through that imagination process is to expand. It's like a parachute. You don't fly until you open the parachute. That is why we have the word be open what? Linda, be open what? Be open what, Linda? Pay attention, everybody. Pay attention. Pay attention. If I recognize that you're not paying attention, I'll let everybody show your video again. So be answering me. I want you to be here. Be open what, Linda?
No, please, can you ask the question again?
You see, you aren't paying attention. That's how I get to know a person is not paying attention. I want you to be paying attention. I want you to forget everything. Else, I'm going to let you all turn on your video. Are you with me, Linda?
Yes, sir.
I don't like people who don't pay attention. I have committed my whole life for the next few hours for you. I've put everything on hold. I want you to put everything on hold. And when you are hiding behind the camera, you are likely not to. That's why I said that the moment we have finished the introduction, I want you all to show your face, but it's not compulsory. And so I was waiting to see who is going to still maintain his or her video. And I can see that you are all gone back to the not being open-minded situation. So be open-minded, because the brain doesn't like to be open. That is why you got to force the brain to be open. Okay. So when you push your brain, it expands. When you push it, it expands. And when it expands further. Because the further it expands, the better you become. Okay, so pay attention, everyone. Pay attention. All right. I'll be giving you a lot of life skills, life knowledge skills. You learn the principle of neuroplasticity and the teleportation of the human mind. I want you to think beyond the way you are thinking. And the only way I can give you beyond this course is for you to pay attention to me. All right. Now, I have put some of the information on Sakai. Have you gotten some emails from me from Sakai? Have you gotten some emails from Sakai? Who has checked the email? Because I've put certain things from Sakai. I want to be sure that. By the way, do you all know Sakai? Yes. Just type yes. So let me know if you know Sakai. Type yes there. If you can't talk. Do you?
Yes, please. We know Sakai.
Okay. Let me know whether you've seen my email later. I give marks for those who participate in class. I give 10% of the marks. So please take note. Okay. Read the textbook, attend all the lectures, do your own private study. I would suggest that commit at least 10 hours a week to this. Commit at least 10 hours a week to this. Never use your job as an excuse. Never use anything as an excuse. Okay? You got to do things simultaneously. That is how you put yourself under pressure. That is when you expand further. Pressure is good. Pressure is necessary. Stress is good. Stress is necessary. Okay? A bit of it, a modicum of that is necessary for you to advance in whatever you want to advance. Okay. All right, and take advantage of anybody who is here. Leverage on the capacities of everyone here. Okay, get to know the people here. Some are advanced than you are. Don't be on your own. You'll be writing a paper by the end of this course. You write a paper like a journal paper. So you should be ready to take an advantage of everyone's skills. All right. So I'm going to show you the syllabus, and I want you to know that some few things might change in the process. But in the interim, this is what we have. Okay. So I'm going to just quickly share the screen and then show you what we have for the syllabus. Can you confirm if you see my screen?
Yes, please.
All right.
Yes.
Okay, so I'm not going to read all about objectives and everything. Okay, I wanted to know some few things regarding the textbooks. Read the textbooks. Okay, all of them are necessary. The website here at the bottom is very necessary to tap into that. Okay, because a lot of learning are ongoing there. There are some of you, if you don't want to install Python on your laptop, you can easily go to this Mindbender. And Mindbender, you can work Python there free without installing Python. So that's really cool, eh? Like sometimes when you're installing Anaconda and then putting in everything, it becomes quite bulky. And you can use this page to be able to get Python installed and used without necessarily having to install Python on your computer, because this uses your browser. All right. Now, there are some, like I said, these things might not be strictly adhered to, but 80% will be adhered to at least. So we'll talk a lot about why you should get rich. Let me put it that way. And what you can do to get rich, more or less. Yeah. Or not rich, but I think the word is wealthy. How you can, because there's a difference between getting rich and getting wealthy. Wealth is a sum total of your integrity, loyalty, virtue, value, wisdom, and money. Money is just a microcosm of wealth. So you will learn about the time value of money, because it's very, very interesting. Because it's not the money itself, but it's the process you undertake. Okay. For example, the topic on capital budgeting, the process you undertake on bonds, stocks, crypto, real assets, financial assets, and even knowledge assets. Okay. How these things you undertake to be able to expand. So who you become in the process of becoming wealthy is more important than becoming rich, because becoming rich is just an abundance of money. There's nothing alongside it. And any fool can become rich, but not everyone can become wealthy. So you will learn that. You'll learn a bit about portfolio management. And not just learning, but how to use machine learning techniques to learn that. You guys have learned unsupervised learning, haven't you? You've done the difference between supervised and unsupervised, have you?
Yes, we did unsupervised last semester.
Good. So you'll use some of the techniques of unsupervised learning to be able to do portfolio management, stock price prediction, fraud detection, loan default prediction, prediction of bank churn rates. Okay. You will use that for the principles of sentiment analysis. You will learn the principles of reinforcement learning. You will do multi-class classification and predicting of credit ratings. All of these are things that you'll be applying your knowledge on. So those of you who said that, Ernest, were you the one who said you want to learn how to, well, it wasn't Ernest. One of you said you want to learn how to use this thing, and the role of analytics in finance? Was it you, Ernest, or someone else? Who said you want to
Yes,
learn the
please,
role
I
of?
did, and Richmond also said same.
Okay. So that is what what I just showed you. You see the role of analytics in all of this. Okay. Now, do you see my PowerPoint slides?
Yes, please.
All right, let's move on. So I'm going to start by sharing with you artificial intelligence, machine learning, data science. What is the connection in all of this is very important. Machine learning and data science. What is the difference, by the way? I think I have a slide that will explore the differences because sometimes we use those terminologies interchangeably. Machine learning, data science, analytics, business analytics, AI and all of that. I'll just show you something very soon. But this whole area is changing the finance industry everywhere you go. And the next couple of decades, it is doing some great things for managers, portfolio managers, traders, chief investment officers. They are benefiting a lot. They are using it for portfolio management. They are using it for stock price prediction. They are using it for derivative pricing, fraud detection, loan default prediction, corporate credit ratings, bank churn rate predictions. Now, if you don't know any of these things, don't worry. We'll look at some of them practically. Okay. There are robo advisors development, and then there's a chatbot development. Some of you have used it when you are on the website or on the page of certain banks or on telecom companies, and you use most of these, some of these chatbots in your work. And AI is helping fast track all of this. So someone might say that, what is the advantage or the role of artificial intelligence, machine learning, or data science? How is it helping when it comes to finance? How is analytics helping with finance? Well, if you have heard about algorithmic trading, they use something called algo. They use this algorithmic trading. They use that to conduct trades, autonomously, and then it can help you calibrate the trading decisions in real time. You're able to know which particular trade item or stock item to actually handle. And you see that happening. Okay. And AI can help you automate that principle so that you can sit in the comfort of your home for it to do your work for you. In portfolio management, we have robo-advisors. Robo-advisors are AI algorithms, used to calibrate a financial portfolio. Okay, whether you have a particular stock or several items in your stocks. And it can detect your risk tolerance. And once it's detected your risk tolerance, it can then advise you what to do based on the goal you want to achieve. So what you do is that you enter your goal. Say, I want to retire at the age of 65. And by that time, I want to have 1 million savings. You now give your age, you give your current income sources, and the assets you have. This robo-advisor will spread your investment across a certain asset classes so that you'll be able to achieve that goal by the age of that 65, and you become a millionaire by that age. It's a very powerful, technique, analytic technique in finance. And a lot of people are using it. So that's why people say that the rich continue to be rich, because they are able to use some principles, which are advanced to be able to do that. You see, the reason why it is good is this. Even if you have a financial advisor for you, that financial advisor can trick you to be able to do. But once you have a robot that is advising you, that robot is not going to trick you, because so you have total autonomy over the robot, and you're able to manage everything with that. Now, analytics have been used also in fraud detection. you can combat fraudulent financial transactions using a lot of machine learning models. The machine learning model will scan a lot of data sets. It can detect unusual activities. It can calibrate security threats. It can know who is entering into the system. And based on, for example, suppose you just go to your bank, I mean, physically, you go to your bank today and you tell them that you need 20,000 pounds or 20,000 cedis. Now, depending on the time you are, they will have to check, why do you want that money? In fact, sometimes the limit on your account is in such a way that you can't even take that money. But if you want that, something is precipitating that. So they got to know, either you are being false, either you are being, so sometimes certain heavy transactions that go on in a split second when someone does not have a particular amount of money, and within a short period, money has hit the account. These machine learning models are able to flag them instantly, and it will be able to detect what the situation is. There's no need to have a checklist of risk factors, and you can use this to do a lot of fraud detection. It's been helping a lot of companies, big think tanks, to be able to detect fraud. So let me just go back to, oh, and by the way, you can use this thing to handle things like fraudulent activities in money laundering. For example, in money laundering, you can use these approaches to be able to detect in case a particular money is being laundered, in any transactional facility. I told you we'll look at the relationship between data science, business analytics, machine learning, artificial intelligence, deep learning, and all of that. So this is what I want you to know. Data science is more or less within the computer science, mathematics, or statistics department. That is a kind of umbrella language they have there, data science. You don't normally see in most business schools, you don't see the word data science, because once you do that terminology, it doesn't sit well with a business environment. So they call it business analytics. That's what they call it, business analytics or analytics. But it's the same thing, or not the same, it's a similar thing being used in the world of data science in those other departments, like mathematics, like statistics, and like computer science. The principles that they are using, the techniques that they are learning is the same. But then the business schools want to apply it more to business-oriented environment. And that is why they call it business analytics or basically analytics. Now, under this analytics or data science, you have artificial intelligence. That is routing. Now, when you go to data science, there are other things you will learn apart from artificial intelligence. There are other things you will learn, but majority of the things are artificial intelligence. The same way when you go to business schools and you are doing analytics, business analytics, apart from the umbrella artificial intelligence, there are other things you'll be doing. For example, you'll be doing things that are corporate finance. You do database management. You will do business intelligence. You will do management science, okay, or operations research. And some of these things are not necessarily under the umbrella of artificial intelligence. Okay. That is why, artificial intelligence does not encapsulate all of this. And when you go to artificial intelligence itself, inside artificial intelligence are machine learning. And inside machine learning is deep learning. And of course, inside deep learning, you have a lot of convoluted neural networks, and Gen AI, all of these things are within. But you want to know that artificial intelligence is bigger, and everything within the area of machine learning is inside artificial intelligence. There are other things inside artificial intelligence that are not necessarily machine learning. And you want to take note of that. sometimes people talk about computer vision, and several other things that you will learn, not necessarily here, but you will learn when you want to pursue the whole umbrella of machine learning. So let's focus on machine learning, because by talking about analytics in business or in finance, machine learning tools are what are being used. And under machine learning, there are three major, but there are 4 or 5, but there are 3 major umbrella names of machine learning. The first one is supervised machine learning. You have unsupervised machine learning, and then you have reinforcement learning. You have other ones like recommendation systems that are also there. So what is the difference between supervised and unsupervised? You've learned this already, so I'm not going to take much of your time. But hey, for those of you who have not learned this, on your textbook, you have it, you should learn it. But we'll talk about them as we go. Okay? But just understand that supervised learning, you have a task. It's a task-driven activity. Okay, your goal is to predict a next value. So you have something and you want to predict the next value. Unlike unsupervised learning, where it is more data-driven. So you have the data and you want to find out what is inside the data. That's it. You want to find what is inside the data. But with supervised learning, you already know what is inside the data and you want to use it to know the next thing. Unsupervised, the data is there, but you don't know what is in, so you want to look through and find out what is it. Reinforcement learning is where you are learning from mistakes. Okay. Anytime you hear the word reinforcement, it's like something is not complete, so we got to come and complete it. Okay. Reinforcement learning, you are learning from errors, experiences. You are looking at associated rewards or punishment from what you do. So here you have an agent. The agent observes the atmosphere of environment. The agent will select, and the agent is a machine. The agent will select and will perform some task. Based on the task, the agent will receive a reward or a punishment. Now, because the agent machine learns that if I do this, I'll get a reward, the next time it will reinforce the agent to do more of that thing to get a reward. But if it does another thing and it gets a punishment, the next time it will reinforce that agent not to do that thing in order not to get the punishment. That's it. That's the reinforcement learning. Okay. And that is what these 3 areas of machine learning actually look at. We'll do a lot of models development. We'll apply a lot of models, and we'll use the Python software to do that. I've already given you a video on how to download, and I want to believe at this stage that you all have Python on your laptop. Python is just one of the soft packages, software that you can use to do machine learning. It's not the only one. Even MATLAB, some use. I use R a lot. R is more for statisticians and mathematicians. Python is a general purpose driven, so it's for everybody, particularly applied analysts. So not only mathematicians and statisticians, but applied, where business executives, people in the real market systems, they enjoy that one because it's more, you have a lot of support for it. For R, you also have a lot of R is deep, but it's a little bit technical. Let me just put it down. But both of them will do a lot of machine learning model development. There are some major packages that you need to have, and these packages I've shown you here. When you want to do data representations, okay, you will need packages like NumPy. When you want to deal with the tables, pandas, you use them. Okay. You have SciPy for machine learning statistical analysis. You need SciPy, you need scikit-learn, you need stat models. Okay. Later you use Keras, and TensorFlow, where you have to download those ones separately and bring them into the work. If you want to do a lot of visualization, Matplot library, Seaborn, you use that. When you want to manage packages, like you reinstall, force and install a lot of new things, you use PIP and Conda. So these are some of the Python packages that you'll be dealing with. They are not exhaustive. The major thing I want you to know today is the 7 steps modeling process in Python ecosystem, because you will use these 7 steps plus or minus a certain percentage to be able to do all your machine learning development. It's very, very simple, but they follow a particular system. And guys, note something. I told you that you'll be writing a journal article. You will use these same steps when you are undertaking your research or journal article. I'll give you a couple of journal articles for you to be guiding you, for them to be guiding you, so that you know how to go through these processes. Anytime you are a consultant or you are a researcher, you will go through these steps directly or indirectly. You go through these steps and be able to build your machine learning model and then write your research article or write your executive business report. It's the same approach. The first step is to identify the model goals. What is the problem in the model? We'll look at that. After that, you will load the data and you will load the packages that you need. The packages are called libraries sometimes in Python. Sometimes when you are using R, they use the term packages. In Python, they use the word libraries. Once the data is in the system, you can now explore the data. You do EDA, exploratory data analysis. You do a multiple visualizations, multiple descriptive analytics. You see, in the world of business analytics, you have the diagnostic analysis first. That is more or less like the problem definition stage. Then you have the descriptive analytics. That is where you do a lot of exploration, data exploration, and visualization, and statistical analysis. Then you do, and of course, you do other things like regression and model building. And then you will do predictive analytics. And finally, you do prescriptive analytics. So the whole business analytics are diagnostic, descriptive, predictive, and prescriptive analytics. And I know you may have come across this already. Anyway, so the EDA stage, you do a lot of descriptive statistics and data visualization. From there, you go to stage 4, where you prepare your data. Everything in data analysis, that's why it's called data analytics or data science, is data driven. So if your data is bad, you're in trouble. So you got to clean the data. You got to remove, adjust, transform, do feature engineering, feature selection, and all sorts of things. So that the data is now clean, virgin. We call it virgin data. Now you're looking at the virgin data in your eyes. It's clean, it's pure, it's virgin. And now you can run your model and do the performance analysis on the test data. You can understand the variable modeling intuition. You can save the data. You can use it to deploy models later. And then you can go and do the next stage of, let me go back. So after your data preparation, you can now evaluate your data. I jumped. You can go to evaluation of your data. You can train your data by first doing training and testing split. So you do 80% training of your data. You do 20% splitting of your data. Now, what does that mean? We'll learn this. But basically, you take a portion of your data, a certain percentage of your data, like 70 to 80%, where you will do your analysis. And then the other portion, you will use it to come and validate what you've already done. because it wasn't part of the analysis to see that whatever model you have built, even if you take something from somewhere, it will fit into the model. There are a lot of evaluation metrics you use, to compare, to check whether what you have done is correct. And you do a lot of comparison analysis. Then you can tune in the model to enhance it. You use a lot of hyperparameter tunings. You can use great searches here, but you can also do random search and other ways to do your work. You learn that hyperparameter tuning the model is like setting a certain. Oh, that's right. Okay. Setting a certain setting for what you want. So for example, if you are doing microwaving of food, you tune in the thing to high, medium, or low. Or in case you want to have a radio channel and you want to listen to a particular piece FM, you tune in to the right frequency that you want. But the same thing that you use, okay? And you use a great search to do that. And finally, you can have a complete model. So these steps are what you go through to be able to come out with your model development. But because this is what we are going to do, I want to pick them one by one and show you basically what you need to know about this. And please remember, after this, I'll take you straight to Python. And then I will not walk you through this. I will walk you through certain basic things you need to know about Python and model development. And if you have not downloaded, please download whilst you're talking, because I've already told you to download. I know you've all downloaded already. So let's start with the problem definition. Let's try to understand how to go through, how to apply analytics towards any finance problem or any problem at all. Don't worry, we'll still use a lot of finance work. So the first thing you want to do is to have a problem and then define it. For example, it's telling students to come up with a topic. Or those of you who are consultants, somebody brings a problem to you. You need to shape the problem. You need to define the problem. Make the problem a problem. So first thing you want to do is ask yourself, what is the problem? Second, why is the problem a problem? What is the problem? Why is the problem a problem? How does this problem relate to other problems? To what extent is this problem bigger or smaller than other problems? Make the problem a problem. So much so that you become worried to the extent that you want to handle it. So first you will describe the problem informally. And then you will state the problem formally. What assumptions underline the problem? For the problem to be a problem, what things must be in place for the thing to be a problem? And like I said, what are other problems that are there? List the benefits of solving the problem. Why do we need to handle this problem? So you can see that if you have done research before, or you've written any thesis or dissertation, or even done an executive research, you know that that is a process you are going through. That's why analytics is becoming, because this will fit into any industry, any setting. And then, so tell us why we need to solve the problem, the benefit of solving the problem, and how, if we should solve the problem, how will the solution be used? So you see the problem alone, because if you don't identify the problem well, you just be, doing mumbo jumbo, running through activities left, right, and center. You got to magnify the problem. You got to make a problem very explicit, precise, and concise. Describe how the problem will be solved using your existing knowledge, the domain knowledge that you have. So you don't just get up and go and solve a business problem when you don't even understand that business environment. I want to do credit scoring analysis. I want to see which people will default. You don't even understand loan default. You don't even understand loan. You don't understand the mechanics of loan. You don't understand what goes into the loan. Then you say you want to do loan default prediction. You don't just do that. Understand. Take machine learning out. Take analytics out. Understand the atmosphere, the ecosystem in which you are looking at. Understand the industry, problem. Understand the issue at hand. And then once you have the clear understanding, you can now go ahead and do the analytics. Now, during this program, you will learn a lot about training a model or creating a training model and then a test model. What does it mean to train a model? I want to flag that before we proceed. What it means is that you are teaching the model to recognize data patterns. I'll give you an example. Suppose that somebody gets up and then the gong beater. Remember back in our days, we have the gong beater. The gong beater would get up in the morning and that would do boom, 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 boom. And then he goes, talks about what the king wants to say to the village. Suppose each time the gong beater does that, the next 1 hour, it rains. Every time the gong beater will do that subsequently, it rains. What are you likely to conclude? You can tell me. What are you likely to conclude? What are you likely to conclude? Seth, are you here? Richmond, go ahead.
Please, you can conclude
I'm here, sir.
that there is a correlation between the gong beater and then what the rain.
Good. What are you likely to mistakenly conclude?
That whenever the gong beater beats the drum, it rains.
When in fact, what?
Whenever the gong beater beats the drum, it rains.
Yeah, that's what you wrongly conclude.
Yeah.
That whenever blah blah blah. But when in reality, what is a fact? Or what could be the fact? Because when you say whenever the gong beater beats the drum, okay, then it rains, you are establishing causality, isn't it?
Yes, please.
But then there might not be any causality. There might not be, it's not the gong beating that is leading to the rainfall. It could be that the rainfall, okay, is what is bringing about the situation.
Okay.
You just don't know. They are only correlated. Or for all you know, there's no correlation at all. So what are the patterns? What are the hidden items? What are the underlying patterns? So when you are training a model, you are teaching that model to recognize the unseen, the things invisible to the eye, so that it will be able to use those things to predict. And you see, I'm using the word to predict, which is some sort of a kind of a regression analysis, or to classify, which is some sort of a classification analysis, not a regression analysis. So that when you present that model with a new data set, it will be able to predict, because you've trained it to recognize the pattern. So once it's able to detect what is going on here, what's going on here. So anytime, and it's able to know what is going on, the next time he recognizes what is going on here, whatever thing that was used to handle what was going on in A becomes the same thing as what is going on in B, you will be able to use that solution to handle the same thing here. The process of going through riots and eventually provocations and eventually escalations, and eventually it leads to a complete war. When you're able to detect that in a particular country, and then after some years, you start detecting similar things in another country, the patterns, the handwritings on the wall, you would now be able to know that what happened here is the same thing that is going to happen there. And so you are able to quickly use what has happened and the solution you gave to this one, you are able to quickly use that to address the second situation. Training a model is key in analytics for finance. It involves feeding data into an algorithm. What is an algorithm? Who can tell me? Because people use this term, anyhow. What is an algorithm? Linda, what is an algorithm? Seth.
Sure, I would say an algorithm is a set of instructions that you give to a computer to execute.
Good. So it's a procedural analysis. It's a procedural instructions. Okay. So the algorithm has to be there. So anytime you get something, you feed that into the algorithm. So the algorithm must be there, meaning that it has to be developed. And then after you've given the instruction or you fed the data into the procedural instructions of the algorithm, you can now adjust the parameters based on the patterns you've recognized. And then you can minimize possible errors or mistakes to improve the accuracy of the model. This whole process is what we call training a model. Guys, you are going to be training models. You will train a model from the beginning to the end. But you can't train a model unless you have a clear problem. And problem definition is very, very key. All right, so that's the first part. The second part is that once you have identified a problem, you want to now load your data and load your packages. Because now your problem is clear, which means you have your data, you have your everything. Normally you will load the data, it is in this sort of raw form. So you need to, first of all, have the libraries. And I've mentioned a number of the libraries. Pandas and NumPy are very popular ones. Matplotlib, all of them, PyPlot, all of those things, yeah, very common. You will load the data, but if the data has got some delimiters, it has some comments. For example, sometimes you have AB00412. You don't even understand what they mean. So there are some things that are within the data, you have to remove them. And then you can import the necessary packages. So let's say that you want to import a CSV file, a comma delimited file. You can now, and let's say the file is XYZ, you can use this command to be able to import the data. Sometimes you have another data, okay, and you can give it a name. In fact, some people use data, some people use DF. Okay, these are the terminologies you're going to see a lot. You can use that to read the data, making sure that it's got the necessary things like this, the file names, the names, and all of those things are there. We'll go through a couple of examples. And you can now, if the data has got any other item, you got to specify some of the item. But if you've already organized it nicely in Excel, then it will pick it up as it is. So that is the second stage, which is loading the data and your packages. It's not a joke, especially when your data has got issues. It's no joke. So what do you do? Now what you do is so it's not a joke when it has issue. When it has issue, you got to clean the data. You got to do a lot of cleaning, a lot of interpolations, a lot of adjustment, a lot of missing data handling, a lot of zero handlings. A lot of things has to be done to have a virgin data, more or less. And now you can go and do your exploratory data analysis. Okay. The first part is descriptive analytics or descriptive statistics. You can view the raw data. You can check the dimensions of the data. You can check the types of data, whether it's a float, whether it's an integer, whether it's a string, whatever attributes of the data, you can check it. You can summarize, you should summarize the distribution of the data. Everything about a distribution of the data, the central tendencies, the measures of the central tendency, the mean, the median, the mode, the minimum absolute deviation. Then you check the spread of the data, the range, the quartile range, all of the possible quartiles that you want to check, the standard deviation, the variances, the kurtosis, the skewness, all of the necessary things you got to check. You check all of them, and how they are connected. Okay, whether there are possible correlations, creating contingency tables to see. You got to have a feel. And see, sometimes you might not even know what is in the data until you do all of these things, and then you'll be able to have a feel. So sometimes by looking at the data, you realize that, ouch, that problem I thought was a problem, this is even more of a problem than that one. And then you can use that to handle it. I have a couple of examples. So I want you to go to your work. We are going to use the one I gave you to show you slight example of that. Okay. So, no, not here. Let me just. I want to just go through. The first thing you should do is that normally when you open, so first of all, you must have downloaded and installed Anaconda. Okay. Then after downloading and installing Anaconda, you now open Anaconda Navigator, which is here. And when you open Anaconda Navigator, you see that it has a lot of applications. For example, it has data spell, it has Jupyter Lab, it has Jupyter Notebook, it has Spider, it has Deep Note, it has Oracle, depending on some things you are doing. It has PyCharm and it has R. All right. Now, in this very example, we are going to use the Jupyter Notebook. So once you know we are going to use a Jupyter Notebook, you click Launch. And once you click Launch, this is what you're going to have. It's going to launch your Jupyter Notebook for you. And this is Jupyter Notebook. Everything you have already opened will open. Other than that, it will go to this main page like this. Okay. This main page, if you check, it is your sort of working directory. And what do I mean by working directory? The working directory are things or the place where your entire files should be. The entire Jupyter Notebook should be loaded onto. Now, it could be your My Document, and you can always also change it. It could be your My Document. So let me show you where mine is. So in my computer here, I have something like this. See, this is my PC. So this is my PC here. And in my PC, I have my C drive. Okay. So if I double click my C drive, I hope you guys can see it. Can you see it?
Yes, please.
If I double click my C drive, it takes me to users. And if I click my users, it takes me to the name of my user. My username is ZBook. That's me. Okay, maybe yours will be your name. Maybe yours will be something else. Mine is ZBook. When I double click ZBook, that is where I chose as my sort of working directory. So every file, every Jupyter Notebook file that I have is here. I have analytics for finance. I have L1 model development blueprint, the one I gave you. I have everything. Okay. If I had used my document as my sort of working directory, then that is where the thing. So every CSV file that you have, in my case, I have put it here. Whether it's a starter file, it's a MATLAB file, or anything, I've kept all of them here. So this is my working directory. And in fact, let me show you something. If you ever want to know where it is, you can always ask. So all the files at the bottom, as you scroll down here, you see that folder. Everything you see here is in that folder. Everything that you are seeing here is inside that folder that I just showed you. The green ones that you see, the green items are those that are currently running and how long they have been running. Now, if you want to open a brand new file, you can click here at the top here and click new. And when you click new, you can choose Python 3 or any Python kernel level that you have. The current one I'm using is Python 3. Once you click this, watch something. Once you click this, bam, a new Jupyter notebook is going to open. And remember, the interface here is just like your browser. So this is brand new, very, very brand. There's only one cell there and the cursor is blinking. These things, these cells are where you're going to be typing. You're going to type anything there, okay? And because I've not labeled this document, it is called Untitled 6. You can click this Untitled 6, and then you can name it. Let's say you call it Dr. KOA, and you click rename. You can then rename it, okay? And then that's it. I am canceling it. If you want to create more cells, you click this plus symbol, and you can create. In fact, some people will create more cells, getting them ready. You know, click, so that it's like you have a page, getting them ready for things. Some of them you use it as a sort of Microsoft Word by changing the code to Markdown, which you can use to do your write-up. And then some you use them actually for coding. And then by keeping this section here as code instead of Markdown. And then you can use it for your work that you want to use it for. Okay. So this is brand new, and then later on you can save and rename it, okay? And then you can check your file, and then you know that you have this file now saved. Now, let's take another example. Let me close this one. Hold on a second, it's frozen. Oh, it's asking me changes you've made, blah, 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 blah. Leave, okay. Now, suppose I have another one. So let's say I have another one. And I have a file already there. Okay. Suppose I want to know where is my working directory. So the one I have given you guys is this. Okay. Suppose I want to tell you where is my working directory. And this is my first cell. Okay, so this is how the cell is. If I bring the first hash, it's a heading. But before this, I want to create a cell. Before this very cell, I want to create a cell here. And then bring this one, rather, I want to copy this, cut, change this cell to a Markdown so that I can use it sort of like Word. And then create it. And now above that, I want to indicate the software to tell me where is my working directory. To do that, I'll type import OS, the operating system. Use small letters. Import OS. Oh, this one is in Markdown, so change it to coding. Okay. Import OS, and then we are going to request that it gives you the working directory. So we type os.get working directory bracket. So I'm going to run this, okay, and then it will import the operating system library, and it will check where is your working, because if you don't know where your working directory is, and somebody gives you a file, you probably want to dump it into your working directory so that you directly work from there. And it's really nice, instead of mostly using the URL. So once you click enter, and how do you click enter? You can do control enter, or you can come here. Anytime you can click run at the top, okay, and it will run the command. Or you can do control enter, it will do the same thing. So it's running. When it's running, you see the stars. Okay. So when you have a mistake there, you will always get some mistake. It's fine. Okay. It's fine. Okay. I made some typos. So get CWD. That was the right word I'm supposed to type. So you type get my working directory from the C drive, and then you do enter. Okay. So you see that now it is telling you that the working directory is in the C drive under users under ZBook. So this will help you to know where all your items are going to. And you can always drop your item. If somebody gives you a CSV file, a starter file, an Excel file, you can take it there and then you can work with that. So I just want you to know this. And you can now, because when someone has created a thing for you, when someone has given you a document like I have given you, if you don't take care, you will not know how it all started. And it all started blank, like I've given you that blank. All right. So now you have your working directory. And anytime you type in a markdown, you can do control enter to show it, as a heading, if you want to show it as a heading. Okay. Basic things that you have in your packages I've given you are this. Learn about these things yourself. What is a text type? Okay. What is a numeric text type? We have integers, we have float, we have complex. What are the sequences? Okay. We have list, we have tuples. All of these things, you've learned them already. Okay. Dictionary, setting your data types, a Boolean type, okay, a binary types, okay. For the purpose of this class, we are going to mostly use text type, we are going to use numeric types, we're going to use sequence types, you're going to use mapping types. Okay. Anytime you bring in a code, okay, you see this cell here, it has code. Anytime you start typing in a code, and you want to use it as a kind of a guide, an instruction, your own note you're making, you bring a hash in front of it. It's just like you would have done in R. So here, what I did is I type my name and I print my name. So if I learn these things yourself, they are very self-explanatory. Learn them yourself. If you want to show your results, you just do print. And then if it is a string like this one is, you have to bring the apostrophes, okay, with them. Because if you remove these apostrophes, okay, let's say I remove the apostrophes, it's no longer a string. If I run this thing, it gives you an error. Okay? But that is because it is a string. So you got to put it in apostrophe for it to know that it's a string. And once you click it, it will show you that it is unnecessary. So those are text types. Okay. You also have numeric types, numbers. And for numbers like this, you're using it as a calculator. 5 plus minus 1, which is 5 minus 1, which is 4. Okay, you tell it to print the result. Every time you tell it to print the results, it will give you the results down here. You can do the same thing for numeric types, do for sequence types. A sequence types means that you are typing them, all of them in sequence. So you are telling me, use this one and use it for this one and use it for this one and use it for this one. So for example, you have an X and you told me that Python that X is made up of 2, 4, 6, 1, 1, carry and carry. Okay, look at that. Look at it. Carry, one of the carry is double apostrophe. One of the other carry is also 1 apostrophe. That is the same thing. It's a string variable. Okay, so if you execute print X here, it will give you the same thing, but watch it in the results, it's telling you that the carries are the same, so there's no problem. That is a list. You can also create a tuple. A tuple like this, y equals to 419, it's a sentence, okay, mixed with numbers. Okay, once you type that and you say, show me the results for that, you print that, you also get this. You can create a range that I want a z value to be 6 for the end should be inside a z should be that. So it's going to give you a range of between 0 and 6. And once you print this n, okay, it's going to give you the first item, and then once you show the final n, it's going to give you the value of the description that you have given right here. Most of these things are self-explanatory. I want you to learn them yourself. If you have something like x equals to 5, print and tell me the type of x. Okay, x is an integer, so it will tell you that the class of x is an integer. The usual hello world is a sentence. It's a string variable. So if you ask for the type, if it has been defined as x, this x is a string variable. So you see, x has been defined with an F5. X has been defined with a hello world. All of them, when you want to check for the type, they are different because of how you have defined them. You can mix a number and a letter. Okay, that's a complex variable. For example, S is 2J. That's a complex variable. So most of these things are self-explanatory. If you want a dictionary, you bring a curly bracket. Curly bracket beside something is a dictionary because you're defining something within another. If you want a Boolean is something that is either true or false. So if you say that X is true, and you want to know the type of X, because it's a Boolean, it will tell you that the class of X is a Boolean or a bool. But you can try some things and you get some mistakes. For example, X is nothing. So if you ask it, what is the type of X? It will tell you that it's nothing, it's invalid, because you've not actually defined anything. So those are what we call the basics. And I want you to learn these basics on your own. Okay, these basics, learn them on your own. Okay, now suppose you have the document, the one I gave you, and now you want to find out that document. How do you find it? Suppose you are here and you want to be able to identify something else. You are in one section here. You want to go to, let me close this. You want to go to something else, okay? You want to open a document which already is there. How do you open a document? So you click, let me show you here. You click File, you click Open, and it will bring you to the working directory. And inside that working directory, you can open whatever you want to open. So that L1 model development is here. Okay? That L1 model development, that is it. So at this stage, if you wanted to just click on it to open it. So I'm going to click on this, and it will open that file, that Jupyter Notebook. Oh, and for those of you who don't know, the Jupyter Notebook always will end with that, you know, like the way a CSV file will end with, you know, CSV. This will always end with IPYNB, okay, indicating that is a truly Jupyter Notebook file. So you see that anytime you have IPYNB, it's a clear Jupyter Notebook file. So even if you use Word document to try and open it, you're rather going to get a mistake from that. So this is the file you guys have. Okay, that's the one I gave you. And you have it all there. And you can see how I opened it. You can use that same approach to open it. I'm going to go back to our analysis. I'm going to go back to where we were in the slides so that we can proceed why we got to this section in the first place. So I was trying to show you a file. So here I had a file, actually, and the file is WM. It is wearing masks. Okay. The actual file is called masks. It's a data set of during COVID-19, the number of people who were wearing masks. And this is a CSV file. And so I want to import this CSV file into Python. How do you do that? It's very simple. Okay. So what I did, which you may have, okay, I didn't give you that one. So what I did is I used the command import NumPy as NP and pandas as PD. And basically the one you are using focus on is pandas. You use pandas as PD to read a file, and this will load the data set. If you want to see the head of the data, you can see the head of the data. This one is telling you that show me the first 12 rows of the data. If you want to check some information about the data, you can check some information. So many things you get. In fact, the information about the data is powerful because it will give you the types and everything about the data. So this WM, which is the name of the data, the way I labeled it, you can call it any name, to give you the information. You can check the shape of the data, the dimension of the data. You can also do a descriptive statistics of the data. It will not give you everything you want. Like R will give you a whole bunch of descriptives. This one will give you selected descriptives, like the mean, the median, and a couple of quartiles. Okay. 25th percentile, 75th percentile, and a couple of other things. So you can do that. Now, the next step in the process, you remember, was exploratory data analysis. I'll come back to the one I've given you, don't worry. In exploratory data analysis, you can do visualization. Apart from doing the prediction, the descriptives, you can also do visualization. You can do a lot of univariate plots, histogram, density plots, strip plots, violin plots, box plots. Can do a lot of multivariate plots, correlation matrices, scatter plot matrices. All of these are here. You can do several of these plots. You got to do these things in your work to show. And you will see that some journals I'll give you, they've all done this. I want to quickly, because next week I'm not going to treat this. So I want to quickly show you some important things here. The difference between training and testing data. What is the main difference? Because you'll be dealing with this all of the time in your work. A training data is a data that is used to train a model. And remember, this whole idea of training data is more for supervised learning. It's not for unsupervised learning. It's usually for supervised learning. That is why we train and then we test. And the difference between a training data and a testing data or test data is that for a training data, you're using that data set to train the model and fit the parameters. In other words, to find the coefficients of the model. And then you will use a test data to evaluate the performance on the new or unseen data. So you train this one, and because it's learned the patterns, you use that to the second one, to the test data, to evaluate the performance of the training data on this new unseen data. What is a training data used for? It is used to fit a model. And it also is able to learn the relationship between the features. Now, the features here are, if you were doing regression analysis, you might say that they are the independent variables. Okay, so it's able to learn the relationship between the dependent variable, which is the target, and then the independent variable, which is the features. You're able to learn. Now, remember the word learn. Okay, once it learns the target, that is the main thing. The main thing is for it to establish that causality or the relationship by learning. Then the test data is used to evaluate the model, because you built a model on the training. Okay. You use a test data to determine the performance, to assess the performance of the model that you have fit. The training data has a direct exposure during training. So that is the one you are working on. Okay, so that is the one that comes closer to the fire. Whereas a test data has no exposure to the model during the training. And that is why you notice that the test data is usually at 20% to 30%. The other thing, oh, there you go. So the size of the training data is usually between 70 to 80%. That's a bigger section because you need a higher sample. And then the test data will have the smaller portion, which is 20% to 30%. What is the impact on the model, the training or the test? The training data affect how the model learns and adjust. Okay. But then the test does not affect the training or the adjustment of the model. So when you are actually, developing a model, the training data, will affect how the model is learning and how it's adjusting and all of that. And if you want to do evaluation, the evaluation metric, well, for the training data, the model training error is identified, and then you try to, minimize the error from there. In the testing, you focusing more on the metrics, okay, because you are not really dealing with the errors, you are focusing on the metrics. So you are using a lot of metrics, checking the accuracy, checking the precision, checking the call, sometimes called the confusing metrics. You use that to check for the testing. I want you to go and learn the differences, by looking more at examples in the textbook to know the training and then the test data. All right, so now let's go to step 4. Okay, I'm showing you the 7 blueprint approach. So you prepare the data and pre-process the data. Remember, the data is inside your software. You have to clean the data. You have to check for validity. You have to check for accuracy. You have to check for completeness. You have to check for uniformity, unit of measurement. Check whether the unit of measurement are the same. If they are not the same, okay, then you have to, because some of them can be in kilograms, some of them can be in dollars, some of them are in thousands, some of them are in millions. Check in the uniformity. Drop not available values. Fill in not available values with zeros. Fill in not available values with a mean. How do you handle all of this? You are cleaning. Data cleaning is very key. And then you do feature selection. But before that, so feature selection. What are features? I've already told you. The features are the underlying inputs, okay, the factors within, especially in the supervised learning. The features are used to train the model. So if you have an output like the dependent variable and input like the independent variables, the features, the independent variables, are used to train the model, the machine learning model. And those features can affect the performance of the model. Why? Because if the features are wrong, the performance of the model will be wrong. The model will not perform well. So what feature selection does is that, it will try to identify which features are contributing the most towards the prediction of the target variable. And then those features are selected. Feature selection is a very nice, it is used a lot in supervised machine learning models, like I've indicated. It can help you to reduce overfitting. Overfitting is a very powerful concept that you will learn later on. All of these things, you're going to apply them later, but I want some of them I'll flag and tell you to go and read on your own. Okay. When you try and make a model decide, not based on noise or complexity, you are reducing overfitting. But there is overfitting when the model is making a decision based on noise. And when I say based on noise, it's based on like complexity in the data or errors in the data. Why do you decide based on errors when you are infected? It's like having Alzheimer and then you are making a decision for a government. The decision may be infected by the fact that you are not thinking straight. Because you can forget all the people in the room, can forget the things you've even said, and you said that you didn't say that. So you have that noise, that complexity in the data. That's overfitting. And once you use feature selection, you can handle that noise, that complexity in the data. So feature selection is good. It also helps you to improve the performance of the model. And it can also help you to reduce the training time, because if the model has got wrong features, the time it takes to train the model is very, very long, And so you got to do feature selection to help you deal with that. Now, to do feature selection, you will use something called select best function. It is under sklearn, okay, scikit-learn, and it will drop those irrelevant features from the data. We'll do that. We'll practically do that when we come to loan default and applying it to stock market prediction, derivative analysis, we do that. Okay. Step 4, still on step 4. Once you have done the feature selection, you remember you clean the data, you've done feature selection, you can now transform the data. Yeah, some of the data needs transformation. For example, you have to rescale all the attributes to the same scale. For example, you can say that the attributes should all be within the range of 0 and 1. That's called rescaling. And these commands will do some of those rescaling. From sklearn, okay, you can use minimax scaler to do the rescaling. We'll look at that. You can standardize the attributes or the features. Okay. When I say standardize, I mean some of them are not normally distributed. So you can standardize them to be normally distributed with a 0 mean and then a constant variance. Okay. With a 0 mean, that is with a mean of 0 and a standard deviation of 1. You can transform, the transformation process will mean that you are normalizing the data. You are standardizing the data. So data standardization is very, very key. And there's a package called standard scaler, which we'll use for this standardization. So understand rescaling, understand standardization, and then the final one is normalization. These are all transformation processes. Normalizing the data means that you are rescaling each observation to have a length of 1. Okay, and it's very, very good for sparsely populated data. You use the package called normalizer to be able to do this thing, and we shall do an example of that. But you might, in your own small ways, try and read around this. If you want an information about this, you can always ask. It's in the textbook, but you can always ask, and I'll give you information about it. And by the way, those things can take just 5 minutes. Okay? They are not that long. It takes a few minutes to do. And then finally, towards the final section, you will evaluate the model itself. Now that you've done all of this, you know, the most important thing is trying to do all of this. Now you got to split your data into training and test split. What does that mean? You will take the original data and you split the original data into training data and then test data. The training data usually is 80%. The test data usually is 20%. You will use the training data to train the algorithm that you have developed. And then you use the test data to predict and assess the prediction against the expected results that you are looking for. Now, what is the difference between the train and the test data? The differences can lead to meaningful differences in the accuracy of your estimate. There's a function called train test split. That function will be used. It's also in sklearn. That will be used to do most of the training and splitting of this data. After you've done the training and splits, you will now identify which evaluation metrics you are going to use. So you're going to select which machine learning model you will use. For those who are supervising the masters, the postgraduate students, some of them say, I want to use this, I want to use that, I want to use this model, I want to use that model. You don't get up and say, I want to use this model. You can't just say, I want to use this model. You have to do a lot of model building. You have to develop a lot of models, and then you rather select which one to use. You select which algorithm. And this is an art. It's a skill. It's a science. There's not one solution, or there's not one approach that fits everything. You know, for example, you can build a model using X to predict Y. But you have to use Y to predict X too. So you got to understand what you are doing. Sometimes one model can help you here, but will not help you there. So you need that skill to be able to do. And by doing some of them along the line with me, then you will now get that skill. Okay. Now, after you identify the evaluation metrics, you can now compare the models and algorithms. Okay. We don't know we don't have any idea about which algorithm will do well on any particular problem. Okay. Sometimes you have to use linear regression. Sometimes you have to use polynomial regression, which is quadratic related regression. Sometimes you have to use cubic regression to fit, y on x. And then based on that, you have to use all of, based on that, then you select which one is a better one. How do you evaluate which one is a better one? You have to use the root mean square error. Okay, where 0 means that there is no error at all. It's perfect model. Then based on that, you can say, oh, I don't want to use the linear one anymore. I would rather want to use the cubic one because the linear and the quadratic one are not good. So I'm going to use the cubic one. How do you evaluate that? You use the root mean squared and other things to be able to check whether the model is good. So you compare, and that will help you to know which model. So sometimes when you read the papers, you see that it will tell you that this is good, this is not good, and all that. Now that you've selected that, okay, I'm going to use this cubic. Now you have to find the best combination of hyperparameters of the model, and you do that by, because there's a problem, okay? And that process is a search problem, and it is called model tuning. I've already given you an idea about model tuning. This is one of the most important steps in model development, because the fact that the thing is selected doesn't mean that it has the best. So yes, instead of washing the thing with your hand, you decided to use the washing machine. But by using the washing machine, do you want to indicate that the thing is silk, or is cotton, or is polyester, or what? Okay. So by using the washing machine alone is not enough. You got to tune it to the cloth that it is, so that you can have a good work. What are hyperparameters? Hyperparameters, we will look at this detail, but for now, know that they are environmental factors of the model that are used to control the training process. Okay. You can consider them as the settings of the model. I gave you an example of tuning a microwave from high to low to medium and all of that. But unlike the model parameters, unlike the coefficients of the model, okay, unlike the model parameter, you set these hyperparameters before you start the training process. Okay, you set it before, but then usually the model parameters is, during the training process. And so, how do you do that tuning? The tuning is achieved by searching the best parameters using a method called grid search. Now, we'll use grid search alone, but like I told you, there are other ones you can use. But for this course, we'll be using grid search. What a grid search does is that you use that one to uses each of the possible hyperparameter combinations. So sometimes you want to increase. Let's take, for example, oven. You want to set the thing to 250 degrees, but also at medium, or you set the thing to 300 degrees at high, because even at high, you have maybe 300 degrees to 350 degrees. So within the high level, what combinations? So different hyperparameter combinations can be used to be able to now achieve the best model that you have. And like I said, the other ones, random search is there, Bayesian optimization is there, hyperbrand is there. We'll do all of that using our examples that we have. I have an example of data set that I've done in your work. Okay. What I'm going to do is, in our next meeting, I'm going to take that example. In fact, I want to rather tell you to go and do it yourself. Go and do it yourself. Okay. So here are the things. I have a model. Let me show you. I'll show you an example. Okay. But for now, let's look at the final model. The final model will run a prediction on the test data with the trained data. Okay. We do performance on the test data. We select the model during the training steps. We evaluate it on the test set. The test set will just allow you to compare the different models in an unbiased way by basing the comparison in the data that have been used. And when we start doing all of these things practically, you will understand. And then you can now do model intuition, where you look at a holistic view of the approach taken to solve the problem. You look at the limitations of the model you use, the desired outcome, the variables you use, and all of that. You can save the work and deploy the work to use for other machine learning models that you can handle. Now, I've given you a link here, okay? In saving your work and deploying it, you can check it. Do not do it, but sometimes you save your work and deploy. There's a beautiful Microsoft website that has a way of, saving your work and deploying it and then using it for further works, okay, which you can look at there. For today, that is how we are going to do. When we meet next time, what I'm going to do is we're not going to start with a practical model. I'm going to take you back to finance. And then we're going to learn how to be rich. That's the first one. Or how to be wealthy using the principles of finance and machine learning approaches. We're going to look at the whole knowledge of time value of money. We're going to look at time value of money. We're going to look at the principle of present value, future value, okay, whether to go to school and do MBA or to rather use the money to invest it in the stock market and see the benefit of all of that. We'll consider capital budgeting, the net present value of items, whether to buy a car or to build a house, which one is better? If you have a 3,000, it doesn't matter which currency, and you are earning 3,000 as a salary, whether $3,000 or whether 3,000 rand or 3,000 cedis. How can you still become a millionaire between 20 to 30 years? Even if you are earning 3,000, at least 3,000, how can you become a millionaire with that principle? Okay. And then several things that will apply. We'll apply and model it in using Python in all of this. So that's it. That brings us to the end of the entire caboodle. If you have a question, please, you can ask the questions